Hi, I'm Sai Krishna. So let us look at the question number 2. In question number 2, we are given the joint density function fxy as b. We are given a condition for x between x and y as x square plus y square is less than or equal to 1 and 0 otherwise. Okay, and then in the part A, we have to we have to calculate the value of b so that the above is a valid joint density function. So let us look at the solution for this. So question number 2, we are given fxy x comma y as b for x square plus y square is less than or equal to 1 and 0 otherwise. In the part A, we have to calculate the value of b. Okay, so for this we can use this infinity to infinity fxy of x comma y dx dy is equal to 1. So here, see, I can definitely say that this is the condition. So if you draw the condition, this is a circle, and here the 1 implies that this is the radius is equal to 1. Okay, so this means that there is a circle of radius 1. Okay, and we are double integrating it between for dx and dy, between the dimensions dx and dy, which means that the area has to be b into pi and r square. R square is 1, so it is 1 square, so 1 pi into 1 square has to be equal to 1. That means that b equal to 1 by pi. So we have calculated the value of b as 1 by pi. So let us look at the part B of question number 2. So in the part B, we have to calculate e of x given y, e of x given y, and so on. So for this, let us first calculate the value of e of x. So for this can be given as double integral minus infinity to infinity minus infinity to infinity x into fxy of x comma y dx dy. So this can be written as 1 by pi integral minus infinity to infinity integral minus infinity to infinity x dx dy. So here this can be written as 1 by pi between the limits minus infinity to infinity integral root over 1 minus x square minus, I forgot minus. This is because if you take the circle and take the y coordinates of it, anywhere, any point on the circle, this is 1 minus x square and this is minus of 1 minus x square. So these are the point of y, because x square plus y square is less than or equal to 1. That implies that y is less than or equal to 1 minus x square root over. So I'm just substituting that here, x dx dy. So we can this is dy dx. We can clearly see that this is an odd function. That implies that this is 0. That means that e of x is equal to 0. That implies e of this is 0, e of this is also 0. So the first 3 terms are 0. So this one, this one, this one, all 3 are 0. So let us calculate e of y now. E of y is equal to double integral minus infinity to infinity root over 1 minus x square. I'm keeping the same integrals here. So this is y into fxy x comma y dy dx. So this is minus infinity to infinity integral 1 minus x square 1 minus x square, and this is y into b into dy dx. So this is also a odd function. So this means that this is also 0. That means that e of y is equal to 0, e of y given x is 0, e of y given this is also 0. Okay, so that means that these three are also 0. So now look at e of x comma y, that is equal to double integral minus infinity to infinity xy of fxy of x comma y dy dx. This is equal to double integral minus infinity to infinity root over 1 minus x square minus square. So I'm first integrating y, so x is the thing, b into y into dy, and this is dx. Odd function, that implies that this is 0. As so in this way I've done the part B. So let us look at the part C. So here, as e of xy is equal to e of x into e of y, they are uncorrelated. So in this way I've solved the question number 2. Thank you.